Did you know that antibiotics have saved millions of lives since their discovery? But how exactly do they work? Let's dive into the world of antibiotics. To antibiotics, antibiotics revolutionized medicine in the 20th century. Before their discovery, infections that are now easily treatable were often fatal. Antibiotics function by targeting bacteria, either killing them or preventing their growth. This allows the body's immune system to effectively eliminate the infection. Antibiotics can be classified into two main types: bactericidal, which kill bacteria outright; bacteriostatic, which stop bacteria from multiplying. Once in the body, antibiotics travel through the bloodstream to find and attack bacteria. They work at the cellular level, disrupting bacterial functions. Antibiotics are ineffective against viruses like the cold or flu. Viruses have different structures and replication methods that antibiotics can't target. Today, antibiotics are crucial in treating infections and have dramatically reduced illness and death rates. However, their misuse can lead to resistance. Overuse and misuse of antibiotics can lead to resistance, where bacteria evolve and no longer respond to medications meant to kill them. This is a growing global concern. Scientists are constantly researching new antibiotics and strategies to combat resistant bacteria. The future of medicine depends on responsible antibiotic use. The history of antibiotics. Long before modern science, ancient civilizations used moldy bread and other substances to treat infections without understanding the science behind it. In 1928, Alexander Fleming made a groundbreaking discovery with penicillin, the first true antibiotic, revolutionizing medicine and saving countless lives. Penicillin became widely used during World War II, drastically reducing deaths from infected wounds and diseases among soldiers. The mid-20th century saw the discovery of more antibiotics, such as streptomycin and tetracycline, broadening the ability to treat various bacterial infections. By the 1950s, antibiotics were being used to treat common infections, reducing the mortality rate from bacterial diseases significantly. Overuse and misuse of antibiotics have led to antibiotic resistance, a major challenge in modern medicine that requires careful management. What are your thoughts on this ongoing issue? Let me know below. Today, research continues to develop new antibiotics and strategies to combat resistant bacteria, ensuring the continued effectiveness of these vital medicines. Educating the public about the responsible use of antibiotics is crucial to maintaining their effectiveness. If you're finding this useful, a quick like would be amazing. How antibiotics identify bacteria. Antibiotics often target the bacterial cell wall, a unique structure that provides protection and shape. By disrupting the cell wall, antibiotics can weaken or kill bacteria without harming human cells, which lack these walls. Some antibiotics identify bacteria by targeting their protein synthesis. They bind to bacterial ribosomes, halting the production of essential proteins needed for growth and survival. Antibiotics can also target the DNA replication machinery of bacteria, preventing them from multiplying and spreading the infection. This stops the bacteria from reproducing effectively. Antibiotics work in two main ways. Bactericidal antibiotics kill bacteria directly. Bacteriostatic antibiotics inhibit growth, allowing the immune system to eliminate the infection. Selective toxicity is crucial. Antibiotics are designed to target bacterial cells specifically, minimizing harm to human cells. This selective action is what makes antibiotics effective and safe for treating bacterial infections. Antibiotics exploit differences in bacterial metabolism. By targeting specific metabolic pathways unique to bacteria, antibiotics can effectively disrupt their functioning without affecting human cells. Pathogenic bacteria have specific markers that antibiotics can identify. These markers help antibiotics to distinguish harmful bacteria from beneficial or neutral bacteria in the body. Antibiotics often work best in tandem with the immune system. While antibiotics target the bacteria, the immune system mounts a defense, ensuring a quicker recovery. If you're finding this useful, a quick like would be amazing. Mechanisms of killing bacteria. Antibiotics work in two main ways. Bactericidal antibiotics kill bacteria directly. Bacteriostatic antibiotics stop bacteria from growing, allowing the immune system to eliminate them. Some antibiotics, like penicillin, target bacterial cell walls, preventing the bacteria from building a protective barrier. Without this wall, bacteria cannot survive. Certain antibiotics interfere with bacterial ribosomes, the site of protein synthesis. This prevents bacteria from making proteins necessary for their growth and survival. Some antibiotics target bacterial DNA replication machinery, inhibiting bacteria from multiplying. This stops the spread of infection within the body. Antibiotics like polymyxins disrupt bacterial cell membranes, causing essential contents to leak out, leading to bacterial death. Some antibiotics block key bacterial metabolic pathways. By inhibiting processes like folic acid synthesis, they prevent bacteria from growing and reproducing. Overuse and misuse of antibiotics can lead to resistance, where bacteria evolve to survive despite the presence of antibiotics. Responsible use is crucial. Bacteriostatic antibiotics rely on the immune system to clear infections. A strong immune response is vital to fully eliminate bacteria. Understanding how antibiotics work helps us use them wisely to preserve their effectiveness. If you're finding this useful, a quick like would be amazing. Antibiotics versus viruses, why they don't work. Antibiotics are powerful medicines designed to fight bacterial infections. They work by either killing bacteria or preventing them from multiplying. However, they have no effect on viruses, which are structured differently from bacteria. Bacteria and viruses are both microscopic, but they are fundamentally different. Bacteria are single-celled organisms that can live independently, while viruses are smaller and require a host cell to reproduce. Antibiotics can destroy bacteria by attacking cell walls or interfering with their ability to reproduce. This targeted approach is effective because bacteria have distinct structures that antibiotics can exploit. Viruses lack the cell structures that antibiotics target. They hide within host cells, making it difficult for antibiotics to reach them without harming the body's own cells. Some common illnesses caused by viruses include the common cold, the flu, most sore throats, bronchitis. Using antibiotics for viral infections can lead to antibiotic resistance, a serious public health threat. It's crucial to use antibiotics only when prescribed for bacterial infections. Vaccines work against viruses by preparing your immune system to recognize and fight specific viruses. Unlike antibiotics, vaccines prevent viral infections rather than treat them. Always consult a healthcare professional before taking antibiotics. They can determine if an infection is bacterial or viral and prescribe the appropriate treatment. If you're finding this useful, a quick like would be amazing. Understanding the difference between bacteria and viruses helps us use antibiotics wisely. They are a precious resource in fighting bacterial infections, but are ineffective against viruses. What are your thoughts on this? Let me know below. Types of antibiotics and their uses. Antibiotics are classified into various types based on their structure and mechanism of action. Understanding these classes helps in choosing the right antibiotic for specific bacterial infections. Penicillins are one of the earliest discovered antibiotics, effective against many bacterial infections. They work by disrupting the bacteria's cell wall synthesis, leading to cell death. Cephalosporins are broad-spectrum antibiotics used to treat a wide range of infections. They are structurally similar to penicillins and are effective against bacteria resistant to other antibiotics. Macrolides, such as erythromycin, inhibit bacterial protein synthesis, making them effective against respiratory tract infections and skin infections. Tetracyclines are versatile antibiotics that treat infections like acne, urinary tract infections, and chlamydia. They work by preventing bacteria from producing proteins necessary for their growth. Fluoroquinolones, such as ciprofloxacin, disrupt bacterial DNA replication. They are used for serious infections like pneumonia, urinary tract infections, and anthrax. Aminoglycosides are powerful antibiotics used mostly in hospital settings for severe infections. They work by binding to bacterial ribosomes, disrupting protein synthesis. If you're finding this information useful, consider giving a quick like or sharing your thoughts in the comments below. Choosing the right antibiotic is crucial. If you have any questions, feel free to drop them in the comments. How to use antibiotics responsibly. Antibiotics are powerful medicines designed to combat bacterial infections. They either kill bacteria directly or stop them from multiplying, allowing the immune system to take over. However, they have no effect on viruses like the flu or common cold. It's crucial to only take antibiotics when prescribed by a healthcare professional. Self-prescribing can lead to misuse, which may result in antibiotic resistance or unnecessary side effects. Always complete the entire course of antibiotics, even if you start feeling better. Stopping early can leave some bacteria alive, potentially leading to a resurgence of the infection. Never share antibiotics with others or use someone else's prescription. Each antibiotic is specific to the type of infection and individual health conditions, and sharing can cause harm. Overuse and misuse of antibiotics contribute to antibiotic resistance, where bacteria evolve to resist the effects of medications. This makes infections harder to treat and increases the risk of disease spread. Antibiotics can cause side effects such as nausea, diarrhea, or allergic reactions. Always discuss potential side effects with your doctor and report any adverse reactions promptly. For viral infections, focus on supportive care such as rest, hydration, and over-the-counter medications to alleviate symptoms. Antibiotics are ineffective against viruses. Always communicate openly with your healthcare provider about your symptoms and any previous antibiotic use. This helps ensure you receive the most effective treatment. If you're finding this useful, a quick like would be amazing. Stay informed about when antibiotics are necessary and be vigilant about their use. Responsible antibiotic use safeguards your health and helps combat antibiotic resistance. What are your thoughts on this? Let me know below. The future of antibiotics and resistant bacteria. Antibiotic resistance occurs when bacteria evolve to withstand the drugs designed to kill them. This makes infections harder to treat, leading to longer hospital stays and increased mortality. Understanding this phenomenon is crucial for developing new solutions. Antibiotic resistance develops through natural selection, where resistant bacteria survive, overuse and misuse of antibiotics, poor infection control in healthcare settings, lack of new antibiotics being developed. New technologies, such as CRISPR and artificial intelligence, are paving the way for innovative antibiotic solutions. These tools can potentially identify and target resistant bacteria more precisely, offering hope for the future. Phage therapy uses viruses that specifically target bacteria, known as bacteriophages, to combat infections. This method is gaining attention as a potential alternative to traditional antibiotics, especially for resistant strains. Global collaboration is key in the fight against antibiotic resistance. By sharing data and resources, countries can work together to develop effective strategies and policies to manage and reduce resistance. Prevention strategies include prudent use of antibiotics, improving infection prevention and control, encouraging research and development of new antibiotics, educating the public on the dangers of misuse. Vaccinations can reduce the need for antibiotics by preventing infections in the first place. By decreasing the incidence of bacterial diseases, vaccines play a crucial role in combating antibiotic resistance. The future of antibiotics and resistant bacteria is a shared responsibility. By supporting research, practicing responsible use, and staying informed, we can all contribute to a healthier future. What are your thoughts on this? Let me know below.